Hey everyone, welcome back. We have mastered collections for handling data. Now let's tackle one of the most important aspects of robust software, which are error handling. Rust's approach to errors is different from most languages. It is explicit, safe, and helps you write more reliable code. So, our today's agenda will be unrecoverable errors with panic versus the recoverable errors with the result enum. Next, we will cover the question mark operator which are used in the Rust for the error handling and for clean error propagation and creating custom error types followed by the error conversion and boxing. Afterwards, we will try building fault-tolerant applications and lastly, we will discuss the real-world error handling patterns. So Rust does not have exceptions like other languages. Instead, in the Rust, we have two main ways to handle problems, which are panic for unrecoverable errors and result enums for recoverable errors. This explicit approach leads to more reliable code and better error handling approaches. So while using panic, you must remember that panic will just terminate your program at the point from where it is arised, and it is used for unrecoverable errors, which means that the program cannot recover from that point at which it was arised. So, for example, in this code, I have declared a variable named as secret number is equal to 42, and inside an if condition, I have raised a panic with the panic function just for an example. So, and for example, after this if code, I have some code as well to be executed by the rest. But since this panic, when this condition will be executed and this panic function got executed, it will immediately terminate the program here and it will not proceed afterwards. So this is how panic works. But such an error handling is not useful in all cases because in most of the cases we want recoverable scenarios after an error occurs so that we can gracefully proceed our application from that error points to a feasible result afterwards. So when we use any libraries in our code and for example when we create a vectors using vector library and we try to and somehow our code calls the index out of bound errors. So this is also the panic situation as per the internal library implementations. But we are offered a way through the option enums that we can gracefully handle that out of bound index scenario and hence we can gracefully proceed from that point. Hence, when we are provided with the recoverable error solutions, the has the rights to the user has the rights to decide that how to handle errors in that cases. Now, the Rust also offers the result enum for the recoverable errors handling. For that, let me illustrate you with the code snippets. So, for example, I have a function here for reading the config file, and it will return a result enum. Similarly, a parse config which will parse the string to check that whether any invalid characters are present in that string or not. Config is declared as a script here, which has only one field named as settings, and it is a string type. Then I have used a config.txt file to read some configs from this file and store it into the config result. And to check on to the config result that whether it is having a valid result into it or it have caused some error. So match this config result on the OK and ERR patterns. In case of OK, it means that content has been successfully read and you can proceed afterwards. On to that contents, you can further parse them with the parse config function which I have created. On that same code, we can again apply the result enum patterns here to check that whether it has the valid config in it or whether it has any invalid characters or syntaxes which can then be processed in the ERR enums, or if the entire reading file content was failed, we can then get it executed in the ERR enum pattern. So this is how the recoverable errors in the result enum can be implemented through the match keyword. However, there are alternative way as well by using the unwrap and expect methods. Unwrap and expect are the inbuilt methods in the Rust for the recoverable error handling. So in general, unwrap and expect methods can be used on option and result type enums to extract the inner value when a value is expected to be present. Both methods will cause a panic if the option is none or the result is ERR. So unwrap actually extracts the inner some value from an option enum or the inner OK value from a result enum, and if unwrap is called on a none or ERR value, then it will cause a panic with a generic default message. So our pass config method is resulting a result enum, hence uh, calling an unwrap function on that result enum will return the value if it if this result enum actually returns the OK enum variant, then the calling unwrap on that will successfully return the corresponding results. But if it throws the ERR up value from that result enum, then the unwrap will cause the panic immediately on that with some of the default messages like the unwrap function is called on the ERR variant of these result enum, or if it is was called on the option enum, then it will look like that option is called that unwrap is called on the none option enum. But with the expect function, you can provide a default error string for your code that if this expect enum is called on the none value of the option enum or if the ERR value of the result enum, then rather than throwing the default message, it will throw a failed to pass valid config on your code. So this is the little difference between unwrap and expect. Both of them will cause the panic on the error values of that enums, enums from the option and result. But they will succeed on the positive part of the option and result enums. Rust also provides us an operator named as try operator for the error handling. This try operator is usually written as the question mark. So let's understand it through a code snippet. So I have imported here a file, a package for the file related operations. And first of all, I'm illustrating here to you for handling the file related errors without the try operator. So if you try to open a file and try to read contents from it, if the opening error arises on the file, we handle it through the result enum variants via the match expression. But with the try operator, the syntax becomes compact. You have to just proceed like this declaration of your variable name and just calling the file open function, and after that just append the operator into it, and it uh, help you in executing and reading, opening this file and reading it further if it succeeds. Otherwise, if it if the opening of the file causes error, it will help you return the error from this point onwards and hence proceeding the afterwards. Hence, the try operator is used in case of early returns when the error occurs in our code. We can also chain the multiple error handling operations with the try operator uh, in the our Rust program, and for that we can do like this. First of all, opening the file and then appending the try operator. After that, reading the username from that file and again appending the a try operator on that to check that whether the username is valid or not, or it is existing or not, and accordingly returning the valid username from this function. Rust empowers us to create custom error types for our application requirements. To do so, you have to first declare a proper custom error for your application. So first of all, define your custom error in form of the enum, for example, a config error, and this config error can points onto the file not found error and string parsing error or the validation error for the strings. After that, we can implement the display uh, for the error user-friendly error messages on the error cases when arises or when we do the file operations. For example, if while opening the file, if a file was not found, then we can write a custom string that config file not found on the respective path, and if the parsing of the configuration failed and hence it is a part of the parse error, we can notify the user that parse error occurred on that string with the corresponding message. Similarly, a validation error string, if the validation error arises on that, afterwards we will be required to implement the standard error trait on this configurer so that the Rust can understand that the configurer is a part of the error handlings into their ecosystem. Hence, after the declaration, whenever the Rust compiler founds this configurer, it will understand it as a part of its own ecosystem. Uh, Other error handlers which are inbuilt in the Rust are already exhibits these standard error traits. Hence, this is required for uh, formal declaration of your custom error as a valid and uh, correct error setup in your application. After that, set up a function in your code that can uh, let you parse multiple configurers that occurred on your files and hence can return the a result enum with that which you can then further analyze it via the match expression so that your main driver program do not get crashed and hence it can gracefully handle the error scenarios or otherwise can proceed successfully with the correct results. So with the on the result load config function which will return a result enum and this result enum will be holding uh, the two values. First one is a data and another is the configurer. So for example, if the path is empty, that is a file path that is provided to this load config, it is not having any path into it. So this can throw the file not found error uh, wrapped onto the ERR result enum, which will return the config error value, the file not found error of the config error enum wrapped onto the string that empty path provided dot to string. Similarly, simulate the some reading and parsing afterwards and then try parsing that reading and check that whether the parsing was successful or the parse error occurred. So on that case, you can use your config error enums parse error to handle with this case. Or if your the provided string is just too large, then this will be part of the validation error, which you can then again return it as an ERR result enum. Afterward, if all these handlings, if none of the error arise, it means that operation was successful, which you can then return the value wrapped as an OK uh, variant of the result enum. This load config will be used by the main function and in the main function you can check on the various file paths as a test cases. On each of the test cases, execute the match expression onto the load config function, which will take your individual file paths from this array. And on each of those iterations, if the operation was successful and OK variant is returned, then it means that config has been successfully loaded and we can retrieve the corresponding values. Otherwise, we will just return a corresponding error string for the further handling. So this is how you can set up your custom errors in the Rust. So what we read today actually holds the multiple significance in real world examples as well. One such example is the web API implementations to handle the various network scenarios like network errors or the HTTP errors, authentication errors, etc. All these error handlings of the network operations, you can simulate it with your Rust program to better grasp all the error handling concepts, and hence you can strengthen your concepts onto this. So this is a basic code snippet for handling the various network errors that occurs during a client-server interactions. So as an example, I have took here 5 common errors that usually occurs. First one is the network error, that the network is slow. That's why the client is able to connect with the server. Or if there is some status code related error, then that will be part of HTTP error. If parsing error occurs, that whether the request object parsing was incorrect, or the uh, if the client some of the body data was not correct, that will be part of parse error. If the client could not get it successfully authenticated on the onto the server, this is part of auth error. And if the request limit of the client is too high, this is part of the rate limiting exceeded error. So these are the API errors that I have here initialized. Then afterwards, I had written the custom some of the descriptive errors message that when these error occurs, the user can get a readable error notification that what actually occurred with this when he made a request on the server. So I defined those like these. Afterwards, I provided the standard error rate on this API error. Since the API response can hold the data of multiple data types, hence it is advisable to make the API response as an struct. So into the struct, the basic data that you can include in it is the status code and the body that will contain your core content of the API response data, and lastly the headers with it. And you can simulate API client as well using a struct. The API client uh, commonly be known as a someone that have a URL with it and an API key with which it validates uh, its genuineness with the server. Afterwards, you can implement the API client, uh, some methods with it that you can use it on for creating a new client or some of the utility functions with it. After that, you can define multiple utility methods on that, like getting user data on that and making an API call with that, and then uh, under that, checking with each endpoints using the match expression, so that for each of the endpoints you can append the corresponding headers and the status codes and the corresponding bodies. to properly simulate that at various endpoints you are actually getting different types of data or the different kinds of errors. So for example, the at the users slash 3 endpoint, I have just written that an error would be returned that rate limit has been exceeded on that, and you can also add a utility method for parsing the response of the entire response that API client is going to be received. And then lastly, in the main function, you have to write your driver code that you are actually uh, using the API client on some of your domains with the API key that you have been given via the API server. And then you are checking with the multiple test users. For each of the test users, you have to use a loop so that you can parse each of the users' requests. And for each of the users' requests, uh, check that whether the user data they obtain, uh, whether it was successful or it got some errors like rate limiting or authentication error or the CTP error like this. So this is how you must proceed while implementing a simulation with the error handlings in the real world examples. Let's conclude it by discussing the best practices of the in the error handling domains. So use the result enum for recoverable errors and use panic for the unrecoverable errors, and create your custom error types for your domain as per your application requirements. Use the try operator for the clean error propagation and making your code more readable and compact, and implement the error trait for your custom errors so that it becomes a valid error in your Rust ecosystem. Provide the context in your error messages so that it would be useful in the debugging, and handle errors at the appropriate levels so that each of the errors cases could be handled properly without disrupting your application executions. Don't ignore any of the error cases. So this was all in the Rust's error handling system. The explicit nature of result enum and the convenience of the try operator gives us both safety and readability. And remember that good error handling makes your applications more robust and user friendly. If you have questions about error handling or want feedback on your on some of your application setup with the Rust error handlings, drop them in the comments. Like and subscribe if you are building reliable Rust applications, and I will see you in the next video. Thank you.